Okay, good morning students. I am making this video after a very long time. Today we'll discuss a few important properties of impulse signal which are very important while solving the problems. So in the previous class we have uh, discussed basic elementary signals such as unit step, then unit ramp and unit impulse signal. So these basic elementary signals we have discussed, and we also took various examples to demonstrate how these basic signals are used while decomposing the signals or while writing the mathematical expression of a signal. So by taking various examples we have demonstrated. Here, the point to note that unit step signal, which is mathematically defined as u of t is equal to 1 for t greater than or is equal to 0 and is 0 otherwise. Here this 1 indicates the amplitude. This 1 indicates the amplitude, and this amplitude may change. In some examples this amplitude may be 2, it may be 3, it may be 1.5, it may be 3.5, so on and so forth. It may be negative as well. But always we have to remember that this coefficient indicates the amplitude of this signal u of t, and it never means like that this amplitude is always unit. Okay, it may change, it may vary. Similarly, in unit ramp, we have mathematically defined it like this: r of t is equal to t for t greater than or is equal to 0 and is 0 for all values of t less than 0. So here we have to once again take a note of that this coefficient here, which is hidden as a 1, is the slope. This indicates the slope. So please keep this distinguishing point in mind very well. Here this 1 indicates the amplitude, and here this 1 indicates the slope, and this slope also may change. For example, if we have a signal r of t is equal to k times t, which means I have a straight line passing through origin. I have a straight line passing through origin, but the slope of this line is k everywhere. That means, let's say at time t is equal to 1, the amplitude will be equal to k. At time t is equal to 2, amplitude will be 2k, so on and so forth. So if you compute the slope of this line, you will observe that slope will be equal to k, and that's why the coefficient associated with the t here indicates the slope of the signal. And similarly, in the same grounds, unit impulse delta t, we have defined that this signal has area under the curve, and area is computed by integration, and if we take this integration from minus infinity to plus infinity, its value, area, its strength will be always equal to 1. So we have to remember here that this 1 indicates the area, or it is a strength, and it is not the amplitude of the signal. So we have to remember these important points, and it is noted that this del t appears only at t is equal to 0, and it is 0 for all values of t, for all other values of t. Means this impulse occurs only at t. There may be possibility that this impulse may occur at some different positions of time. Say for example, this is time axis, t is equal to 0 is the point located here, and if we want to represent impulse signal t minus 4, so this is a right sided shifted impulse. So impulse now here in this case, inside bracket term I will equate to 0, so t minus 4 equal to 0, so therefore t is equal to 4, which indicates that instead of t is equal to 0, now impulse will appear at t is equal to 4. This is what the meaning of this shifting of impulse. On the same line, if this delta t plus 3 is the signal which I want to represent, then after this t is equal to 0, there will be a minus 1, minus 2 and this minus 3. So at minus 3, I will be having this signal. So this is what my delta of t plus 3. So these points I have to remember in mind while solving the problems. And here I have to remember one more important point, that the coefficient associated here this arrow indicates this area. So in both these cases the area is equal to 1. So if I want to represent the signal like this, say for example 3 times delta t minus 2. So this means I have a shifted impulse at t is equal to 2. This is t is equal to 0 somewhere here. Then here t is equal to 2. So at this t is equal to 2, I have this unit impulse delta signal. But here the amplitude of this signal is 3, which means the area under this curve is equal to 3. So these 3 points I have to always remember, that in case of unit step the amplitude is changing, in case of ramp the slope is changing, and in case of impulse we are changing the area. No doubt everywhere we are calling it as a coefficient or amplitude interchangeably, but it means actually in case of unit step it is amplitude, in case of ramp it is slope, and in case of impulse it is area or strength. Once these concepts are clear, then let us take one example. Suppose x of t is a given signal and it is something like this. It starts from, let's say, t is equal to minus 6 and it terminates somewhere here. And this is a simple step signal which has amplitude is equal to 4. If someone asks me to calculate the area of this impulse, then the area will be length into width. I know the length will be this is from minus 6 to 0 it is 6 units, and from 0 to 4 it is 4 units. So length will be 10 and width will be 4 units. So 10 into 4. So this corresponds to 40 units is the area of this rectangle. Now instead of xt, if I want to represent signal like x of 2t, it is a compressed signal. I told you in the previous class that when this coefficient is greater than 1, the signal is getting compressed, and when this coefficient is less than 1, signal is getting expanded. And how we obtain these coefficients? Simply divide these coefficients by this parameter, you will get the coordinate points. So here if I divide minus 6 by 2 and this 4 divided by minus 2, I will get here this point as a minus 3 and I will get this point. Now the amplitude remains unchanged. So now my new area A2 will be equal to, now from minus 3 to 0 it is 3 units, and from 0 to 2 it is 2 units. So 3 plus 2 it is 5 and amplitude is 4. So 5 into 4 it is 20. So my new area A2 is half of A1. And this is very interesting property that I came up with. So in general, if I scale the signal x of t by, let's say, some factor alpha, so that it becomes alpha t, then the, let's say, area of this signal is A1 and the area of this signal is A2, then we can obtain area A2 simply by this property 1 by mod alpha. We are taking mod value of alpha because alpha may take positive or negative value into area of A1. So this is a very interesting property, and this is called as time scaling property, which is applicable to even impulse signal as well. So for example, if I want to find del of let's say alpha t, I am scaling delta t signal, I am scaling it by, let's say, alpha. So if area of this signal is A1 and area of this signal is A2, then I can write del of alpha t will be equal to 1 upon alpha mod alpha into delta t, and this is called as the famous time scaling property of unit impulse signal, which I am using many a times while solving the problems. Later on we'll took various examples to demonstrate how this property is useful. The second property is the product property. The second property is the product property. This property says that if there is some signal like this, okay, let's say this is xt, and if I multiply this signal by, let's say, unit impulse, Okay, I know that impulse occurs only at t is equal to 0. And if someone asks me to find the value of yt, which is a product of xt and this impulse signal, then what shall be its value? So I know that when I start multiplying the left side part of this signal x of t, there is no left side signal available for this impulse. So some value into 0, here everywhere the value of impulse is 0. That means multiplying by 0 with this x of t will result into 0. Similarly, multiplying on the right side will also yields a result 0. So y of t is 0 everywhere except at t is equal to 0. So at t is equal to 0, only I will be having sample value of this x of t, which is denoted as t is equal to 0 as x of 0. So that means if I have a product multiplication, then my y of t will be equal to x of 0, which is the initial value of this signal, or which is the 0th value of this signal x of t. So this is once again a very important property of impulse signal. Suppose impulse is occurring, suppose we took previous example, same example to demonstrate the second second example to denote this product property. Suppose this is x of t, the same signal, okay, and instead of unit impulse, let's say shifted impulse. So here this impulse is occurring instead of 0, now it occurs at t is equal to 2, and this is denoted by delta t minus 2. Okay, somewhere here there is 0. Now when I multiply these two signals, then instead of now 0, which sample I will receive? Obviously the sample which exists at t is equal to 2, because at t is equal to 0 impulse is not present now. This is shifted impulse and it is shifted at t is equal to 2, and therefore the value of this x of t I will receive only at t is equal to 2, because impulse appears at t is equal to 2. Therefore the product xt into delta t minus 2 will be equal to x of 2. So what am I doing here? The thing is that how we can remember or we can understand this property. This inside term bracket equals to 0. So t minus 2 equals to 0. Therefore t is equal to 2. And put this value here to find this value. Okay, this is what the product property or the shifting property of unit impulse, which we are going to use while solving the problems. So let us take first example, a very nice example. Many a times these examples appears in the GATE questions, and it is like this. Solve this integral. This integral is t square plus 4 into delta t minus 3 dt, and limits of integration is from minus 6 to let's say plus 6. Now while solving such problems, what shall be the value of this integral? While solving such problems, one should have to look at where exactly the impulse is occurring. So first step is you have to find where unit impulse occurs. Unit impulse occurs. Okay, so where it occurs. So in this case it is occurs t minus 3 is equal to 0. That means at t is equal to 3 it occurs. Now second thing is that, second step is that I need to plot the time axis from t is equal to 0. The limits of integrations is given up to t is equal to 6 on this side and t is equal to minus 6 on the negative side. I have to check that whether this t is equal to 3 will exist in the given span of time. If it exists, then and then only integration is possible. Otherwise, integration result is not possible. Now, in this case, for example, here t is equal to 3 lies in between minus 6 and 6, and therefore integration of this type computation is possible. So here third step is just take this value t square plus 4 and substitute here t is equal to 3. As I explained, put this value in this function. I am putting this value here. So 3 square, t square means 3 square, which is 9, 9 plus 4. So this is equal to 13. So 13 is the answer of my integration. Okay, so I have to check whether the value of impulse occurring is lying in between the specified limits of integration values. Let us take second example. I is equal to cos square t into del of t minus pi by 4 into dt, and limits of integrations are from minus pi to pi. Now here take a note that first step we have to find where this impulse is occurring, and obviously t minus pi by 4 is equal to 0, that means t is equal to pi by 4, my impulse is occurring, and obviously it lies in within the range. So first is limit is okay, so limit is okay. Then second I have to check the time axis, so for time also it is okay. And third step, now I have to put this value, so cos square t, in this I will put t is equal to pi by 4. Now if I put, then cos square pi by 4, cos pi by 4 is 1 by root 2, so 1 by root 2 square, and it is equal to half. So this is the value of integration. All right, so in this way we can solve the problems. Let us take another problem to bring variety into experience. Let us take this problem. T cube plus 5 into let's say del of t minus 6 dt. I want to find the value of this integral, and the limits of integrations are varying from, let's say, minus 3 to plus 4. Now here, very important point, where the impulse is occurring. Impulse is occurring at t minus 6 is equal to 0, which means at t is equal to 6. Second, I have to check the limits. And it is observed that from t is equal to 0, on the left side it is minus 3, on the right side it is 4, and my limit t is equal to 6 does not lie in between these limits, and therefore integration or the result of integration is not possible, or result is 0. So in this case I can write result of this integration I will be equal to 0, because there is no common term to take a product, and therefore the result is 0. So in such way we can solve the problems. Hope you guys understand this, and any problems or any doubts you are free to comment, and please do like this video. Your likes will motivate me to make more videos. I will keep making videos on a successive syllabus patterns, and I will try to cover entire syllabus within this span of time. So thank you very much. Thank you.